Hey guys, we're going to go over one of our plane problems here. These can be a bit more complicated. There are a lot of different steps that we have to go through to solve these, and there are different ways to solve these. So what I'm going to do is I'm going to show you how I like going about getting the solutions. I think it's a simpler process, and because it's simpler, we make fewer mistakes in the long run. So let's go ahead and get started. If we take a look at what we have on the screen here, we can see that we already have the information for the plane and the wind, and I've already drawn the two vectors. Now notice that both vectors start at the origin. I'll explain why I do it that way in just a second, but to show you how some other people do it, sometimes they like to draw our vectors like this. So if we've got our plane vector, we would draw that normally, and then they like to add the wind vector, connecting it here. Now the reason why they do that is because it's easier to see where the resulting vector is going to fall. But in order to get that, we have to draw another XY axis at the top here. We're measuring our angles. If we don't have a lot of space, things get pretty complicated pretty quickly. Things get messy. And because of that, we can make mistakes easily. So I like using vector components. And I'll show you how the vector components relate to the drawing that I have here in just a second. Let's go ahead and figure out what our components are. So if we're going to start with the plane, well, my x component is going to be equal to the magnitude, which is 200, times cosine, and then we have to figure out what the angle is going to be. Now you might think that we plug in 30 degrees because that's what's given with the information, but that 30 degrees is actually the angle up here. And what we need to remember is that when we are measuring our angles, if I draw another axis to the side here, when we are measuring our angles, we start with 0 degrees here and then 90 degrees, 180, and 270. And we count in a counterclockwise fashion. If I go in the opposite direction, if I go clockwise like this, then that would actually be negative 90. If I keep going, that would be negative 180, and so on. So when we're counting in a counterclockwise way, going this direction, we're going to be measuring positive angles. And if we go the opposite direction, the angles are negative. So looking back at the information that we have here to start, what that means is if this top angle is 30 degrees, the angle that I'm going to plug in is 60 degrees. And I've already done my calculation. This equals 100. To calculate the y component, that's going to be 200 times sine times 60, or not times 60, sine of 60. And then that's going to equal 173. What this gets me is this xy point. What does that actually mean in the context of the problem? Well, what it means is that the very tip of the vector here, the tip of the arrow, that point there is 100, 173. And this is why I like drawing the vectors in this way, because when I'm doing my calculations with my vector components, it makes sense in relation to the drawing that we have. So if we then figure out what the wind is, you'll see how the wind looks. If we do the wind, my x component now is going to be 30 times cosine. The 30 degrees that I'm given, that is this measure here, which means the angle that we're using is going to be 300 degrees, and that equals 15. And the y component is 30 times sine of 300, and that equals negative 26. So again, I have my point 15, negative 26, and that corresponds to this point right here, which is 15, negative 26. Now, once I have the components for the plane and for the wind, I can figure out where the resulting vector is going to go, what those components are. So let's go ahead and figure out what that is. For the resulting vector, I'm going to start off by adding the x values of the plane and the wind together, and then the y values of the plane and the wind. And just to keep everything nice and color-coded, I'm going to draw it like this. There. And so then if we plug in what our values are, we get for x, this was 100, and then the y value was 173. And then if we plug in the values that we got for y, or for the wind, we had 15 and negative 26. And so what that gets us then is a final resulting vector of 115 and 147. I'm going to put parentheses around that really quick. There we go. So now we have our points for the resulting vector. And so that's going to fall if we place that over here, somewhere like that, at 115, 147. Fantastic. Well, now that we've got the components for our resulting vector, it's very easy to figure out what the magnitude is. So to calculate the magnitude, if I call that m, that's going to be equal to the square root of x squared plus y squared. And so that equals the square root of 115 squared plus 147 squared, and that equals 187. So what that then tells me is that I know the point of the resulting vector is going to go from the origin to the point 115, 147. The magnitude of that vector is 187. So now we've got two very important pieces of information. Now we can go ahead and wrap this all up by figuring out what the bearing of this resulting vector is. So let's go ahead and draw another coordinate axis. So we don't get our drawings too complicated. And we'll just draw an arrow here to this point. And that point, as we already have said, is 115, 147. Now what that tells me is if I have a 90-degree angle here, a right triangle, well, that's going to mean that this here, the length of that side is 115, the length of this side is 147. And so now if we think about SOHCAHTOA, we can use tangent to figure out what the angle of what the measure of this angle here is. So tangent equals opposite over adjacent, which means that this is going to equal 147 over 115. And if I use my inverse trig values here, 147 over 115, that ends up equaling 52 degrees. Now again, we need to kind of change this so that we can be talking about where it is in relationship to north and south. When we're using our bearings, we always start with north and south, and then we tell how far east or west we go. So if my degree here, if the measure of this angle is 52 degrees, what that means is for the bearing, I'm going to be starting at north, and then I move 38 degrees to the east. That tells me this value here, starting in the north, going this direction towards the east, 38 degrees. So now I've got that other very important piece of information that we're oftentimes trying to find. So by using the vector components, we can find pretty easily the components of the resulting vector. We can find the magnitude of that vector, and we can also find the bearing. And so we get those three important pieces of information without having to do any super complicated drawings, without having to do anything that makes it more likely that we're going to make a lot of mistakes. We can go through this process the exact same way pretty much for all of these problems, finding the components of the plane, the components of the wind. Then we add the x components together to get the resulting x component. We add the y components together to get the resulting y component. And then I use those to calculate the magnitude. And I can then also use those to calculate the bearing. Now in the next video, I'll show you how to get the angles of the triangle that we oftentimes ask you guys to calculate. But once we already have all this information, that's actually pretty simple. So I like getting this stuff first and then doing the angles last once I already have this information to work with.